Today we will be learning 8D or 10D for HL students, applications of the unit circle. Before we apply what we learned in 8C to maybe the new problems here, let's review what we learned in 8C. We learned two different definitions for the trig ratios. The first one is called the general definition of the trig ratios. So let's review the general definition. For any angle theta, this is its terminal arm. For any angle theta, it must be placed in the standard position. That means the vertex of the angle is placed at the origin, and then the initial arm is placed on the positive x-axis. We only look at the terminal arm. On the terminal arm, we can select any point, and the coordinates of this point can be x and y. And the r is the distance from this point P to the origin. Based on the Pythagoras theorem, this is x, this is y. We know x, y, and r can form a right triangle. So r equals the square root of x squared plus y squared. And then remember, r must be greater than 0, since r represents the distance from O to P. Based on x, y, and r, we can define sine theta as y over r. Cosine theta is x over r. Tangent theta is y over x. HL students, you need to review the other three trig ratios yourself. The second definition for the trig ratios occurred in the unit circle. We still have the same angle theta, and this time the point we will select is the point of intersection between the unit circle and the terminal arm. We still let the coordinates of this point be x and y. Since this is the unit circle, the distance between O and P is the radius of the unit circle. This radius is 1. Therefore, sine theta is defined as y over r. R equals 1, it's just y. Cosine theta, x over 1, it's just x. Tangent theta, it's still y over x. Based on either of these two definitions, we also derived two important trig identities. The first one is tangent theta equals y over x in the unit circle definition, and the y is just sine theta, and the x is just cosine theta. Of course, you also can use the general definition to derive the same trig identity. And the second trig identity we can derive from either of these two definitions is x squared plus y squared equals 1. The x is cosine theta, y is sine theta, and therefore we can have cosine squared theta plus sine squared theta equals 1. But we prefer to write this trig identity as sine squared theta plus cosine squared theta equals 1. And both of these two identities are very important for the lesson today. Right now, let's look at how we can apply A to C to solve the problems in 8D. The first problem is finding trig ratios with one trig ratio given. For example, example 1. Find exactly the possible values of cosine theta for sine theta equals 2/3. Illustrate your answers. We need to find a cosine theta with the exact value. This one reminds me that I'm not allowed to use a calculator to solve this problem. If we are given the sine theta, how can we find this cosine theta exactly without using calculator? We do have two different ways to solve this problem. The first method is use the general definition of trig ratios. The second method is use the identity. Sine squared theta plus cosine squared theta equals 1. This one we derived in 8C. So right now, let's look at method 1. The general definition means sine theta equals y over r. So right now the sine theta is given. It's 2/3. Based on this ratio given and based on the definition, I can let y be 2, r be 3. R must be positive, so r only can be positive 3. Then I need to look for x, because cosine theta equals x over r. So right now I only need to focus on finding the x value. How can I find the x value? Based on the general definition in A to C, we should know x squared plus y squared equals r squared. So we are looking for x, but we know the y value, which is 2 squared, then this 3 squared. So x squared equals 9 minus 4, x squared equals 5. X should have two solutions. When you square root both sides, make sure you put down positive, negative for the square root of 5 yourself. So what is the cosine theta value? There are two possible values for cosine theta. Cosine theta can be positive or negative root 5 divided by 3. So right now, let's look at how we can use the trig identity. Sine squared theta plus cosine squared theta equals 1 to solve this problem. Since sine theta is given, which is 2/3, so I sub 2/3 in for sine theta plus cosine squared theta equals 1. This is 4 over 9 plus cosine squared theta equals 1. Cosine squared theta equals 1 minus 4 over 9. 1 minus 4 over 9, 5 over 9. Then cosine theta, I square root both sides of this equation, the same as x squared equals 5. So when you square root both sides, make sure you put on positive and negatives on yourself. Square root of 5 over 9. Simplify the square root of 5 over 9. It's square root of 5, square root of 9, square root of 9 is 3. So no matter which method I use to solve this problem, I can get the same results. There are two possible answers for cosine theta. Cosine theta can be equal to positive root 5 over 3 or negative root 5 over 3. In my view, both of these two methods are good ways to solve this type of the trig problems. We do have another two problems, example 2 and example 3. In both of these two problems, we are given one trig ratio, then we need to find the other two trig ratios. They're exactly the same as question number 1. However, I'm not planning to apply both of the methods to solve each problem. For example 2, I'm planning to use method 1 only to solve this problem. For example 3, I'm planning just to use method 2 to solve this problem. If you want to know how I can use another method to solve the same problem, you can refer to my answer keys to the notes that I post on ManageBag. Let's look at example 2. You are given sine theta, which is negative 3/7, and we know sine theta equals y over r. Right now, it equals negative 3 over 7. Which value should I have this negative sign? Should I have the negative sign in the numerator or denominator? Remember, your denominator is r. This r represents the distance from the point P to the origin. So this r must be positive. It will never be negative. Therefore, this negative sign will be replaced with the numerator 3 over 7. So I will let y be negative 3, r equals 7. Therefore, I can use x squared plus y squared equals r squared to find the x value. So x squared plus negative 3 bracket squared equals 7 squared. So x squared equals 49 minus 9, which gives me 40. So x mathematically should be equal to positive negative square root of 40, which can be simplified into 2 root 10. However, look at this restriction for angle theta. Right now, this restriction tells me this angle is in the third quadrant. In the third quadrant, if you pick up any point on the terminal arm of this angle, your x-coordinate must be negative. Therefore, I need to reject the positive value. I only can accept x equals negative 2 root 10. After I find out this x value, I can use the general definition of the trig ratios to find cosine theta and tangent theta. Cosine theta equals x over r. Right now, x value is negative 2 root 10, r value is 7. And the tangent theta equals y over x. Y is negative 3, and x is negative 2 root 10. It's 3 over 2 root 10. And the signs of these two trig ratios are consistent with all students take calculus in the third quadrant of an angle. So you will know this cosine ratio should be negative and tangent ratio should be positive. And both of them make sense to me. Let's look at example 3. In this example, we are given tangent theta equals negative 3. And we are also given the restriction on the angle theta. This angle is in the fourth quadrant. Based on those conditions, we need to find a sine theta and a cosine theta. To be honest, method 1 will be a little bit easier to solve this problem. Method 2 will be a little bit more tedious and time-consuming for this problem solving. However, we just take method 2 as in the practice. If you want to look at how we can use method 1 to solve this problem, you can refer to my answer key to this lesson note. So let's use method 2. Tangent theta, and we need to look for sine and cosine. What is the relationship between tangent, sine, and the cosine based on the trig identities? We know tangent theta equals sine theta over cosine theta. And right now this ratio is given, negative 3. If we want to find two unknowns, we need to set up two equations for two unknowns. Right now we got one equation, we needed the second equation. The second equation comes from sine squared theta plus cosine squared theta equals 1. Hope that you guys can realize this is a system of two equations. And the two unknowns right now are sine theta and cosine theta, respectively, rather than x and y. You just take sine theta as x and cosine theta as y. Let's solve the system of two equations. You can apply elimination method or substitution method. I will apply substitution method because I can change the first equation to sine theta equals negative 3 cosine theta. I only need to multiply both sides of this equation by cosine theta to get to the square 1. So right now, sine theta is negative 3 cosine theta. I can sub this negative 3 cosine theta for sine theta in the second equation. So sine theta right now should be replaced with negative 3 cosine theta, then bracket squared, plus cosine squared theta equals 1. Simplify this equation on the left side. So this one should be 9 cosine squared theta plus cosine squared theta equals 1. Combine the like terms. You also can combine the like terms for trig ratios, just like 9x squared plus x squared. So 9 cosine squared theta plus cosine squared theta equals 10 cosine squared theta equals 1. Cosine squared theta equals 1 over 10. When you square root both sides, mathematically, we should have two solutions. Cosine theta equals positive or negative 1 over root 10. However, right now we have another condition for this angle. This angle is in the fourth quadrant. For the fourth quadrant, cosine theta should be positive. So since this angle is in quadrant 4, therefore cosine theta must be positive. I reject the negative solution. We only accept the positive solution. Square root of 1 over 10 can be simplified into square root of 1, which is 1 over square root of 10. You are not expected to rationalize the denominator. If you want to rationalize the denominator, as long as it's correct, you can rationalize the denominator. So the rationalized denominator should be square root of 10 over 10. After we got cosine theta value, we can find sine theta. Sine theta equals negative 3 cosine theta. So it's negative 3 times root 10 over 10. Or you can just place this 1 over root 10 in. So anyways, sine theta is negative 3 root 10 over 10. Or you can just put down negative 3 over root 10 as the answer. Right now we need to look at how we can solve another type of the trig problems in section 2. In this section, we need to learn how to find angles with particular trig ratios given. Compared to section 1, in section 1, we are required to solve trig ratios based on one ratio given. But here, we need to find angles based on the trig ratios given. But before we solve those type of the trig problems, we need to introduce a very important concept. This concept is called the reference angle. What is the reference angle? The reference angle is always the acute angle, including 0 and pi over 2, formed by the x-axis and the terminal arm of angle theta. Let's sketch the angles in A, B, C, D, E here and find their reference angles based on the definition. Theta equals pi over 4. Hope that you all know how to sketch this angle. This is a positive angle. You rotate counterclockwise, starting from the positive x-axis. So pi over 4. What is its reference angle? Based on the definition, the reference angle is an acute angle. Sometimes you may have 0 or pi over 2, formed by the x-axis and the terminal arm. So the reference angle for pi over 4 is still pi over 4. Let's look at the second one. First, let's sketch this angle 2 pi over 3. Where is its reference angle? Acute angle formed by the x-axis and its terminal arm. There are two angles, but I only can find the acute angle. So the acute angle formed by the terminal arm and the x-axis is this one. So this reference angle is based on the visualization. Hope that you know how to find this reference angle mathematically. So this reference angle should be pi over 3. How can we get to this pi over 3 mathematically? It's pi minus the rotation angle 2 pi over 3, which gives me pi over 3. Because I only need another pi over 3 to get this pi angle. Let's look at 5 pi over 4. 5 pi over 4, if I rotate this rotation angle, it terminates in quadrant 3. This is 5 pi over 4. What is its reference angle? Based on its definition, the reference angle should be the acute angle formed by the x-axis and the terminal arm. So this one is the reference angle. A lot of you guys probably can tell the reference angle, which is pi over 4. But how can we find the reference angle mathematically? I can use this 5 pi over 4 minus pi. So I rotate pi over 4 more than pi to get a 5 pi over 4. So this is the reference angle for 5 pi over 4. Let's look at 11 pi over 6. Let's rotate this angle and sketch this angle. So rotate this much. This is 11 pi over 6. It's in the fourth quadrant. Where is its reference angle? The reference angle is here, formed by the x-axis and its terminal arm. And you have to select the acute angle. So this angle is pi over 6. But how can we find this pi over 6 mathematically? I find that I only need to rotate this much for the reference angle to get 2 pi. So the reference angle equals 2 pi minus the rotation angle, which gives me pi over 6. So pi over 6 is the reference angle for 11 pi over 6. Let's look at how we can find the reference angle for this rotation angle, which is a negative angle. Negative angle, you rotate clockwise to get negative 2 pi over 3. A lot of you guys probably can visualize how large the reference angle is already from the graph. But some of you guys want to use mathematical way to find the reference angle of this one. Okay, you can change this one to its principal angle. How can we find the principal angle for negative 2 pi over 3? What is principal angle? I introduced in 8a. So the principal angle is the least positive angle between 0 and 2 pi. So right now, if I want to find its principal angle, I only need to add 2 pi. Negative 2 pi over 3 plus 2 pi is negative 2 pi over 3 plus, let's find the common denominator. It should be 6 pi over 3, which is 4 pi over 3. This negative 2 pi over 3 is coterminal with the positive angle 4 pi over 3. Based on the 4 pi over 3, this is a quadrant 3 angle. The reference angle should be this acute angle, formed by the x-axis and the terminal arm. So this reference angle equals 4 pi over 3 minus pi, which is pi over 3. So this reference angle is pi over 3. Based on these concrete examples, we need to summarize the reference angles for the different quadrant angles. If the quadrant angle theta with this interval, so this interval suggests the quadrant angles are principal angles. So anyways, just remember theta is a principal angle. If a theta terminates in the first quadrant, the reference angle must be this one. So theta r equals theta. When the quadrant angle terminates in the second quadrant, so this is my theta. Where is its reference angle? The reference angle must be here. The reference angle equals pi minus theta. In degree measure, you can say theta r equals 180 degrees minus theta in degrees. If this quadrant angle theta terminates in the third quadrant, where is its reference angle? The reference angle is this acute angle formed by the x-axis and the terminal arm. So this reference angle equals theta minus pi, or theta minus 180 degrees in the degree measure. When this angle theta terminates in the fourth quadrant, where is its reference angle? The reference angle is this acute angle. This reference angle can be found with 2 pi minus rotation angle theta. Here is the summary for how to find the reference angles for different quadrants if theta is a principal angle. And I also hope later on you need to use those relationships flexibly. So theta r equals pi minus theta for a quadrant 2 angle. So for a quadrant 2 angle, theta equals pi minus reference angle. For the quadrant 3 angle theta, the theta can be found by theta r plus pi. For a quadrant 4 angle, the theta can be found by 2 pi minus the reference angle. Right now, let's look at how we can find the angles based on the trig ratio given. Let's look at example 4. Find the two angles theta on the unit circle with this interval such that cosine theta equals 2/3. This problem is also an application of unit circle, but I placed the unit circle as second method. And in method 1, I still want to use the general definition. How can we solve for the angle theta if we know the cosine theta ratio? I summarized the logical steps for you already. Step 1, determine the possible quadrants for this rotation angle theta. How can we determine the quadrants for this angle theta? Cosine ratio is a positive ratio. Based on all students take a calculus. Cosine is positive. This angle theta can be in the first and the fourth quadrant. Step 2, determine the reference angle. Where is the reference angle for each quadrant angle? For the first quadrant angle, the reference angle should be this one. For the fourth quadrant angle, the reference angle is this one. But these two reference angles must be the same. Otherwise, they won't have the same cosine ratio for the rotation angles. How can we find the reference angle? Theta r equals cosine inverse 2/3. I only need to inverse this ratio. Let's use the calculator to find cosine inverse 2/3. And make sure right now we are finding all the angles with radians, since the restriction of the angle is given in radians. Double check if the mode on the graphing calculator is on radians. If it's on radians, let's quit. Then we can find cosine inverse 2 divided by 3. Let's keep 3 sig figures. It's 0.841 radians for the reference angle. After I find the reference angle, what should I do with step 3? Use the reference angle to find the quadrant angles or rotation angles. This is the first quadrant angle, and this one should be the fourth quadrant angle. So for the first quadrant angle, the rotation angle is equal to the reference angle. For the fourth quadrant angle, the rotation angle should be 2 pi minus 0.841. 2 pi minus the reference angle. Let's find this value. It's 2 pi minus this reference angle. So it's approximately equal to 5.44 radians for the fourth quadrant angle. That's how we can use the general definition to find the angles if the ratio is given. Let's look at how we can use the unit circle to solve the angle. Cosine theta equals 2/3. Based on the unit circle definition, this one is the x value. So x equals 2/3 is a vertical line. Let's draw this vertical line. And this vertical line will cut the unit circle at 2 points. Join this point of intersection with the origin up. So join these 2 points up. That's how we can find the first quadrant and the fourth quadrant rotation angles. After you know, okay, this angle can terminate in the first quadrant and the fourth quadrant, when you want to find these two rotation angles, we still apply step 2, step 3 in method 1, in method 2 to find the angle solutions. So we still need to go through reference angle equals cosine inverse 2/3. So the reference angle is 0.841. So then the first quadrant angle is the same as the reference angle. The fourth quadrant equals 2 pi minus the reference angle, which is 5.44 radians. Some of you guys may have a question. They probably will ask, why did you call the first method? use the general definition because I derive all students take calculus based on the general definition. The difference between these two methods is just the first step. For the first method, I use the general definition to know all students take calculus. Then I use all students take calculus to find the possible quadrants of this angle theta based on the sine of its ratio. But for the unit circle method, I use the unit circle to determine the possible quadrants. The other two steps in both of the methods are exactly the same. So some of you guys probably will ask, which method is better? It's hard to say. I personally prefer to apply the first method to solve all the angle solutions when the ratio is given. And then there is another question some of you guys may ask. How did you know this value is correct for the reference angle? You always inverse the trig ratio given, as long as it's positive, and this angle value in radians should be between 0 and pi over 2. As long as it's between 0 and pi over 2, this angle is acute angle. I would like to encourage you to pause the video here and solve for the angle theta in B and C yourself, and then check the answers with my answer later on. For me, I prefer to use the first method, which is all students take a calculus to determine the possible quadrants of angle theta. So I will only apply method 1 in B and C. Sine theta equals 3/5. Sine is positive, so the angle theta can be in the first quadrant or the second quadrant. The reference angle for the first quadrant is this one. The reference angle for the second quadrant angle should be this one. And these two reference angles must be the same. Finding the reference angle only needs sine inverse 3/5. You can use the scientific calculator to find a sine inverse 3/5 in radians. So this answer is approximately equal to 0.644. So I finished step 2 in this problem solving already. Then step 3, I only need to use the reference angle to find these two quadrant angles. So for the first quadrant angle, it's the same as the reference angle. For the second quadrant angle, this rotation angle should be equal to pi minus the reference angle. Pi minus 0.644 is approximately equal to 2.50 with 3 sig figures. Right now, let's look at a C. Tangent theta equals 3. Tangent is positive based on all students take a calculus. So this angle theta should be in the first and the third quadrant. The reference angle for the first quadrant angle should be this one. And for the third quadrant angle, its reference angle should be this one. These two reference angles are the same. So let's look for the reference angle. The reference angle is tangent inverse 3. With radians, the answer is approximately equal to 1.25. Now step 3, finding the quadrant angles. First quadrant angle is approximately equal to 1.25, and the third quadrant angle should be approximately equal to pi plus the reference angle, which is around 4.39 in 3 sig figures. Example 5 is exactly the same as example 4. The only difference between these two examples are, in example 5, all the trig ratios are given as a negative ratio. But the negative ratio only just helps me differentiate the quadrants of this rotation angle theta. So let's look at A in example 5. Sine theta equals negative 0.4. Based on all students take calculus, sine is negative, the angle should be in the third and the fourth quadrant. Reference angle for the third quadrant is this one. Reference angle for the fourth quadrant should be this one. How can we find the reference angle? The reference angle should be sine inverse. Do not put the negative sign into the inverse. if you put the negative sign in, you will see a negative angle. But right now, the reference angle must be a positive acute angle. So we always put a positive ratio in. So we do sine inverse 0.4, which is 0.412. So then we can find the quadrant angles. So quadrant 3 angle should be pi plus the reference angle, which is approximately equal to 3.55. And the fourth quadrant angle should be 2 pi minus the reference angle. It's approximately equal to 5.87. B. Cosine theta is negative. Based on all students take calculus, this angle can terminate in the second quadrant and the third quadrant. The reference angle for each quadrant. Just the same as question A. When we look for the reference angle, do not place the negative sign into inverse cosine. So we only find reference angle with cosine inverse positive 3/4. So this one is approximately equal to 0.723. Then the second quadrant solution should be pi minus the reference angle, which is approximately equal to 2.42. And the third quadrant angle should be plus the reference angle, which is about 3.86. The same method can be used to solve C. Tangent theta equals negative 2/3. All students take calculus. Tangent is negative, so the angle can be in the second quadrant and the fourth quadrant. The reference angle for each quadrant is this one and this one. These two reference angles are the same. So finding reference angle by using tangent inverse positive 2/3 only. It's approximately equal to 0.588. So then we look for the second quadrant angle. It's pi minus its reference angle, which is around 2.55. And the fourth quadrant angle should be 2 pi minus the reference angle. It's approximately equal to 5.70 radians. Here are the homework questions for you to practice to further your knowing and understanding. This is the end of the lesson.